Welcome back to Banana Engineering. Welcome back to the punching tool project. Today I want to build up the assembly with you, and let's get started. Go on File, go on New. This time we want to make an assembly, the standard assembly. Create. So we already made all our parts, so we will have to use a bottom-up approach, and therefore we need the first part. And the first part, the bottom, obviously is the base plate. So let's go on Place and go to the folder where you created your parts. Let's start with the base plate. Bring in the base plate. For the first part, I always like to see all the origin planes. So I'm going to switch on the visibility. And in my case, I want the retaining bolt pointing to the Z-axis. So therefore, I have to place the bottom of the base plate on the Z-X plane. Go on Constrain, take the bottom, take the XZ plane, and make sure this part is pointing upwards. Let's say OK. To make the visibility a little bit better, go on View, go on Visual Style, and switch on the Shaded with Edges. Now we can see the part better. So the next thing we have to do is putting the center of the base plate to the center of our coordinate system. It's the YZ axis. So go on the base plate, go on Origin, take this plane, the YZ plane, assemble, go on Constraint, and now we have to make it center to this plane. Now take care, the part is pointing the other direction, but I want to have it to the positive Z direction. So I have to flip it around. The solution here, taking the flush option. Say OK. Now the only way to move it around is like so, and I want to have the back of the plate matching up with this plane here. So go on Constrain, go on this plane, and on this one, the XY plane, apply, and then we're done. This looks great. Next thing will be the vertical plate. Go on Place, go on your folder, go to the vertical plate, open it up, click once, click Escape. Now I want to place the vertical plate on this level here where it will be mounted. Click on the surface here, click on the bottom surface. That looks good. Take care of the direction of the hole. It has to point to the left side of the assembly. So apply. Now there are several ways for the next position. I take those surfaces, match them up. Now you can see I have to flush it around to have the hole pointing to the left side. Say apply. Now the only degree of freedom I have is this one, and I want to match up the center of the vertical plate. Open it up here, going to the origin, selecting the plane and match it up to the origin plane, or you can take the middle plane of the base plate. Both ways work. You have to flush again, in my case, and now we're done. Next thing will be the guiding block. Place. Open the guiding block. Left click, Escape. At first, we're going to match the surface where we have the contact. those two, apply. Then we have several ways again to match it up, but in this case it would really make sense to make the punching holes concentric, like so. Now the only degree of freedom is turning it around. Now we can search for the middle plane in our guiding block and make this one matching up to the origin plane of our assembly. Next part will be the retaining bolt. In this case, I prefer to start with the concentric constraint. Now, if this happens, that it's point to the opposite direction, you have to take the second solution for the alignment to flip it around, apply, then you go on this surface, turn around, take this, apply. The only thing that's left is that the bolt is turning, so we want to have this surface parallel to the upper surface, for example. Go and constrain, click the surface. Now we have to change the option to angle, take the first solution and click this here. So we have a 0-degree angle between those two surfaces. Say OK. And then we continue with the eccentrical disc. Enter the disc. Now we really got to be careful with the orientation. We start with the concentric constraint. And we have to switch directions because we have to make sure that the lever is pointing below the retaining bolt, like this. We say apply. Now we still can turn and move it around as well. Go on constraints again. Match up the two surfaces like so, apply. And now we are going to open up a plane in the eccentrical disc, the vertical plane, this one, and say angle to this plane here. So later on, we have the option to turn around the angle or to play around with the angle, say like 30 degrees, to show if the assembly is working. Next is we bring in the lever. We start with the concentric constraint. How you can see, we have to flip it around, say apply. Then we want to have the lever matching up with the surface here. So this time go on tangent, select the surface, and here the outer surface. Say apply. Now the lever is still able to turn around. We don't want to have that. Go on origin, take a plane, maybe the exit plane or the other, it doesn't matter. We just take the first. Go on angle, first solution, and make it parallel to the eccentrical disc. Now we have to enter the punch. open the punch, make the punch concentric, matching up with the hole. We have to flip it around, say apply. Now we can turn it and move it up and down. So at first I want to make it tangent as well to the surface of the eccentrical disc. Go on Constrain, go here on Tangent, take the surface number 1, number 2, and apply. That's okay. Now we still can turn the punch, therefore go on the origin planes of the punch, take the next one you like to, constrain, and we can make it with an angle parallel maybe to this one here, or you can match it up with the origin plane of our assembly. That's up to you. Don't forget to save the assembly once in a while. So I will continue with the spring. Place, spring, open. The spring is a little bit harder to place. So what's most important is that you have to find the axis of the spring to make it concentric to the punch. Open up the spring, open the origin, and there you have the axis, the y-axis. Choose the y-axis, go on Constrain, go on the punch, and then you have the spring concentric to the punch. Now the spring is somewhere missing in the assembly. You can go on View, go on Half Section, and choose the YZ plane, and then we can see where the spring has gone and pull the spring downwards, like so. Now you can switch off the half section view. So now we are going to match up the spring tangent to the punch by going back to the assembly, Constrain, Tangent, take the surface, the lower surface of the punch, take the ring here, or the circle profile of the spring, and now they're connected in this point here. Now the spring still can turn. Go to the spring, open up a vertical plane and set this plane parallel or matching up to the origin plane of your assembly. Now the plane is already chosen. Now I have the second selection. I take this plane in the middle and say OK. And now the spring is done. Let's continue with the washer. Go here on Place, and this time we have to switch to Place from Content Center. Go here on the search function and enter in the ISO 7090. We just take this washer over here, enter it, and now if you enter it for the first time, don't forget to click here as custom, and we have to choose the nominal diameter, which is 6 in our case, and say OK, and now you have to save it to your folder. Here it is. Finally, we don't need the origin planes, so we select the origin plane and switch off the visibility. And this time I want to show you the joint function. At first, click the part you want to place and then the assembly. And to make life easier, you go here from automatic to rigid to place the washer like so. Okay, And now you can see the washer is not moving around, not turning around anymore, and we're done. We do the same thing with the next screw, screw number 10, slotted cheese head screw, which has an ISO 1207. Save as custom, M6. The length is 8. This is okay. So I try to use the joint function, selecting the head of the screw and the plane of the washer, trying to fix it with the rigid tool, but unfortunately I can see we don't get the right orientation of the slot. So we go on cancel and insert it manually with the constraints. Therefore we go on constraint, selecting the axis of the screw and the hole, say apply, choose the surface of the washer and the screw here to match it up, say apply, and then we want to make it parallel to this surface, so go on angle, go on solution, go on this surface of this slot and this one here, and you have a 0-degree angle. Say OK, and we're done with that. Last thing is we have to enter the parallel pin and the screw. Therefore we go on the position number 11, hexagon socket head cap screw, go here, place from content center, it's ISO 4762, choose the screw, enter it, left click, save as custom. Now we have an M6 with a length of 16 millimeters. Say OK, save it. Now go on the joint function, select the surface of the screw, go on rigid, and now the place where the screw has to be, like here. Then you say OK. For the second screw, click the screw, go on copy and paste, and do the same step again. Joint, select the surface. You can now choose rigid or later. Rigid. Now that's perfect. I will only show you one parallel pin, ISO 8734. Choose the right dimension, 6 millimeters, length of 22, save as custom, OK. Go on joint, select the surface, and now select the surface like so. Go on rigid. In case the parallel pin is pointing in the wrong direction, you can flip it around here with flip component and say OK. Alright, so far you can enter the rest of the screws and the parallel pins by yourself, and later on you have to choose nice colors by going here on the color selection, choosing a nice color, selecting your part, and then you have a nice assembly that looks like this one. So if you like the video, please hit the like button, and we see in the next video where we're going to make the drawing of the assembly. Bye.